Um, so, in the session today, I just wanted to cover, there's been a lot of discussions on 5G. To really understand what would be the uptake of 5G in the market, one has to really understand what 5G brings to the table. If there is no sufficient gains with 5G, one can always expect the uptake either to be slow or there will be no uptake. So to better understand what really is there in 5G specification today, I'm referring to the baseline being the 3GPP specification which came out in December last year. That is the baseline. So we try to do a critical analysis of what 5G is today. It also sort of gives us an understanding of where it has to go if there has to be an uptake. And then we'll summarize and then we can have some question answer session. So what is 5G? These are the terms you get to hear when you really hear about 5G. So I've just used it as is. It was straight from web. I didn't want to disturb some terminologies that generally goes on with 5G. So 5G is supposed to be a unified air interface that covers a host of use cases scenarios. Primary one being EMBB, Enhanced Mobile Broadband. That was the primary objective of the specification. So as we stand in December 2017 specification, EMBB was the primary focus. Then of course the URLCC, which is the Ultra Reliable Low Latency Communication air interface, is supposed to be superimposed on top of the existing EMBB air interface. And that's work in progress. So we have to see how that goes. It's yet to start. I think it will start from the next couple of meetings, or the meeting which is ongoing in Athens this week. So we'll have to see how that progresses. And then access to new spectrum. New spectrum is where it will be deployed. Higher bandwidth, it demands higher bandwidth. Now that it is, if you look at the nature of the waveform, it's only higher bandwidth that it will work in. So primarily it was focused on millimeter wave waveforms where your bandwidth will have to be high. Lean carrier, we'll see what it does. Massive MIMO, of course, it's inherent of any 5G technology, but I mean, it's inherent to 5G because it's a requirement without which 5G coverage in millimeter wave will be hardly anything. Control channel efficiency, energy efficiency, dynamic tuning small cells, let's see what those are. Dynamic tuning small cells, 5G is supposed to be TDD all the way out, so I mean, you don't have to necessarily make a special mention of it. But I just use the same words as is generally available in the internet because I just want to put it across. This is the popular terminologies which goes on when we talk about 5G. So we want to critically analyze the real gains of 5G technology over LTE. Because it's just about 2 years since LTE has been deployed. Billions of dollars have been invested by operators on 4G infrastructure. Now suddenly if 5G has to be invested, it has to be well justified. So we really try to understand what is 5G bringing onto the table. This is not so much of a session to damn 5G, but essentially to understand what really 5G is bringing to the table. That gives us an understanding of where we have to take this, where 5G stands today and where we have to take this. So this is in summary, we're trying to critically understand what 5G really is today, today if you want to deploy 5G, what it really brings to the table. So, people typically give show gains of 5G NR waveform today with respect to LTE. These are numbers that typically come out. So enhanced beamforming could be for LTE as well. So typically don't want to account for any enhanced beamforming gains. Lean carrier. What lean carrier means is that 5G allows for flexible subcarrier spacing, flexible numerologies. But then again, the specification which is currently out there is the EMBB specification, which primarily has a subcarrier spacing of 30 kilohertz. It's a static thing, so that's a benchmark for any further analysis. URLCC is yet in the cooking, so we don't necessarily have to take that into consideration. But there is some amount of flexibility. For example, if you deploy 5G indoor, there's some flexibility to play around with the subcarrier spacing. But does it really give any efficiency? We'll check on that. And enhanced intercell cancellation. These are things which can be achieved even in LTE. LTE is also an evolving technology. It's not that just because NR is in progress, nobody stopped working on LTE. That's not the case. So which leaves us primarily to now critically look at one key factor, which is the improved spectral usage. That's one of the key factors which, if at all, brings in any amount of gains on 5G. That's one of the things which will really have to bring in changes to the table. Otherwise, the rest of the stuff is something that we can achieve even in LTE and LTE. And primary reason why we're trying to do this is, so if any operator has to buy 100 megahertz of spectrum, it's an additional couple of $1 billion of investment. That's not a simple thing, a couple of $1 billion of investment for whatever spectral efficiency we get for the 100 megahertz. Mind you, the whole analysis is being done with an intention that you also have an option of deploying 4G LTE in the same 100 megahertz that you buy. If I spend $1 billion on 100 megahertz of spectrum, then obviously I need a critical analysis or comparison between LTE and 5G. So let's look at the spectral efficiency gains of 5G NR. So most of the gains seem to come from the way the resource blocks are utilized. There's some amount of overhead reduction in the specification. And so I'm just taking 100 megahertz. 100 megahertz is a benchmark. On LTE, you can have 20 into 5 component carriers, so that's 100 megahertz. 100 megahertz, 100 megahertz, apple to apple comparison. In 100 megahertz NR, you have 917280 resource elements, equivalent 16800 into 5, so that comes to about 7 something. And it's typically understood that in NR, the amount of RB utilization will be much higher when compared to LTE. And that's one of the key things which, how did I get this figure? There's some calculation which goes into it. I think I have some kind of I'm not sure if I have a calculation in place, but the way this number comes up is, for example, if you do, see in LTE it's a contiguous chunk. It's a contiguous chunk of 100 megahertz, whereas in LTE it's a component carriers addition. So there's amount of scheduling overheads which will come into picture. So anyway, we'll take this number. So 90% RB utilization from LTE and 98.2% RB utilization for NR. It's not a big number. If you actually try to map these numbers to commercial figures, to money, it's not a big number. So we can go with this number for the time being. The rest of the numbers are pretty straightforward. How do I get this number of REs, resource elements, which are used in NR for the synchronization signal broadcast channel? It's about 0.21%. The reference signal 7.14% that directly maps to the number of REs which are there. And so we take into consideration some of the gaps when you have to treat the system, when you switch from uplink to downlink. There's about 25% overhead, so discount all those resource elements. In that case, both are TD, so it's the same percentage of on LTE and on NR. So even if you were to do a rough calculation, the total the available REs versus the total REs which are used up in all these other overheads, which are not necessarily used for transmission, you'll see about 78% difference between LTE to NR, approximately about 8% more efficient. 8% efficiency in terms of the raw resource elements which are used for some of the control channels, which are not necessarily used for timing. But if you were to actually calculate the overall efficiency, which is you take the actual REs, that is number of REs minus in the total whatever REs that you find, and divided by the ratio with respect to LTE, you get about 24%. You get about 24% more efficiency on NR, on 5G. And then again, there are other things to be considered. A rough calculation of a carrier aggregated versus a contiguous chunk of 100 megahertz, which is what you get for NR, about 5% efficiency. So, these are all figures from link level simulations. These are not figures from end-to-end system performance figures. We'll come to that. We'll try to add a ballpark figure of how much of these efficiency numbers goes away if you take some of the system analysis parameters into consideration. So, we've not considered any network slicing, orchestration, scheduling inefficiencies because it's very hard to map. Especially in network slicing and orchestration, which happens to be the case in 5G, whereas assuming that the LTE is still working on your legacy whatever mechanism. And then again, we are still considering, we are doing a physical layer mapping consideration. We are not even considering 5G non-standalone scenario, where your control channel is on LTE. That means you still take the overhead of around 7% there with respect to the, we look at the control channel efficiency, that goes away. What will you get here? Because 5G is, NR is nothing but a data pipe for you. So approximately we can come to about, we'll go with this figure of about 24% for the time being, we'll see how much. So one of the key other areas of improvement is the way PDCCH is used. In NR specification, the unused PDCH resources can be pushed onto PDSC. That means this can be used for data transmission. That's about approximately about 4% gains if you look at the number of RBs and if you take some numbers and get some approximate number of. So these are all still theoretical numbers. These are purely based on number of RBs or REs, resource elements that we have for 100 megahertz of channel bandwidth. But if you look at an actual implementation, the way a scheduler works, a lot of inefficiencies come in because of the way a scheduler is implemented. And if you really take some of the loading considerations into picture, nobody provisions to work at full buffer. You will never come across a eNode B anywhere in the country in any technology working at 100%. No. If it hits about 90% load, then you go for reprovisioning. You make sure, there's some kind of a load balancing that kicks in, and you make sure that number of users are thrown off to another cell, or some kind of a load balancing will kick in, but you will not typically cross about 90% as far as the load on a single eNode B is concerned. Now, you're anyway accounting for about 10% there. 10% is left free at any one point of time. Now, we are approximately seeing about all the PCCH gains about 4% and all those stuff. If that is to be accounted for in the 10%, which typically is never touched, you really have a critical understanding of where you stand with respect to gains. We look at a few more figures. One of the other factors which seem to affect the performance is with respect to, this is from a Nokia source. Nokia made a contribution of 3GPP in one of the meetings, and just taken it from there. The way you design your massive MIMO antenna apertures and the way you define the logical arrays is logical to think of, because if you really look at the massive MIMO Red 64 Pro 64, I can choose any number of elements, x cross x as a subset of 64 cross 64. I can use that to form one single beam. And how many number of users do I put on one single beam per TTI? Those are all the questions which aren't coefficients. But if I just consider one single beam, the combination of the elements inside of used to form a beam seem to have an effect on the efficiency of the base station. That's what we look at. And there is NR shows about slightly, it varies, it's something about 19%, about 23-24% improvement in spectral efficiency. But very frankly, when you look at this is purely looking at a massive MIMO aperture antenna considerations. Now, though this is a figure which is available for whatever reason, I think the understanding here is that even if you deploy massive MIMO, this is the fact that you have a contiguous 100 megahertz of contiguous chunk of bandwidth, that's precisely where the gains come in. Otherwise, it's just massive MIMO. It should linearly scale. It should not necessarily, there should not be any difference between LTE versus. So it more or less comes down to the fact that in LTE, whenever we talk about 100 megahertz, it's a cut piecemeal of 5 component carriers of 20 megahertz. That is precisely the singular factor where much of the inefficiency seems to be coming in from in terms of usage. And that also bears a lot on the scheduler efficiencies. So, in summary, if you look at the uplink coverage, I've considered 3.5 gigahertz as a case study here because band 42, which is 3.5 gigahertz band, is supposed to be the one which will be the 5G band in India. That is what the government sources are saying, so that's precisely what I want here. And we still consider 2.3 gigahertz for, which is a band 40, which is a deployed band for LTE in India. If you consider that if you take that into account, if you want to have a similar uplink coverage for NR and LTE, you will need to scale up on the MIMO factor for NR in a big way, 64 cross 64, to reach a 4 cross 4 LTE coverage range. And there are a few other things, but anyway, thumb rule, this is what it is. And there is much more loss from 2.3 to 3.5. There's about 3 dB loss with respect to one wall penetration. That's something that has to be accounted for even. So indoor penetration goes for a toss. So these figures actually tell us where we stand with respect to NR. It tells us what kind of a deployment you could have for NR, what kind of a complementary deployment you could have vis-a-vis LTE. It also tells you, what is the true spectral efficiency you can expect if you were to deploy NR instead of LTE. So overall, even if you assume about 25% spectral efficiency by NR over LTE, with all the other concerns still being the case, is 25% efficiency a justified business case for NR as we stand today? Because to get that 25% gain, I'll have to create a new device ecosystem, I'll create a new base station ecosystem, which is going to take some time, resources, money, and then again, you buy the spectrum today, the vendor ecosystem may not necessarily be in place, so that is something that has to be worked upon by operators. This is purely looking at it from the physical layer point of view, purely base station radio point of view. So there are serious concerns. So as it stands today, if anybody who is gung-ho on 5G, yeah, that's the holy grail, will go deploy. And if you go to any business manager and post these figures and say, okay, this is what we'll get, they'll show you the door. This is not compelling. 5G as it stands today, in terms of pure spectral efficiency over LTE, is not compelling from a business point of view. That's the key message to deliver on this. And then You can always take plus or minus 10%, depending on whom you ask. You go to Ericsson, they might show okay 35% gain. Somebody else might slightly lesser. Take average it out. Even if you take an average about 25%, that's what I've taken. Even 35%, even if you take an optimistic view of another 10% extra, okay, I'll do some super stable, or I'll bring in efficiencies, I'll do all those kind of things. 35% is not very compelling. Because 35%, if you actually look at the usage of a cell over a normalized period of time for some use cases, it's not very compelling. So I'm not trying to damn 5G as a technology, but then what I'm trying to say is, it's just the first specification has come out, so it still has a long way to go. We'll see how much, what is the scope for improvements in subsequent releases. So this is about just the physical layer. Let's look at the overall use case scenario from a service point of view. From a 5G is supposed to bring in a lot of things. It's supposed to, for the first time, bring in disaggregation as a specification. Disaggregation in the sense, for example, virtualized core, virtualized everything. Virtualized everything means operator gets to gain in terms of hardware, in terms of software, in terms of cost. It's supposed to bring in all those, and it's supposed to be very closely integrated into the service model. What service model means is you're trying to bring the data to the edge, edge computing, edge analytics, edge intelligence. 5G is supposed to bring in all those. So we'll take a critical analysis of where the rest of the specification stands. Yeah, of course, I'm not trying to say 3GPP. It's not a right judgment at this point in time because only the physical layer specification is one which is complete. But then 3GPP has a roadmap for the future. 3GPP has a roadmap for release 16, release 17, which is in the books. So even if we take that into consideration, we get to do a critical analysis of how 3GPP is geared up to give us a service architecture or a service environment or a platform for virtualization. The virtualization specification is split across multiple groups. I mean, it's not just 3GPP. But then again, this is some total of all the specification which is there in place. There are certain challenges, and that's precisely what we want to understand. So you saw the efficiencies, some of the efficiencies. Some of the physical layer efficiencies, what it says is even to get those high level of efficiencies from base station point of view, you need to have 64 cross 64. That's not a big deal. I mean, everybody is talking about MIMO. Any investment in 5G will consider MIMO into consideration. So 124 cross 126, 126, whatever configuration you might have on the base station. But then again, even on the business side, this is definitely not, 5G is definitely not for your mobile handle. Though you go to MWC, there will be a ton of people who will be showing this. The last time I went to Qualcomm booth, 28 gigahertz, they had a phone. They had a 5G phone. And I was very curious, I was inquisitive. I was asking him, how do you do this? What is it? 5G chip, and they're showing. They had a setup where in a line of sight in 28 gigahertz band, it's 28 millimeter wave, it's not 3.5, not sub-6 gigahertz. They were showing about coverage-wise, they were showing about 150 meters, a non-line of sight. So non-line of sight was 150 meters coverage. They didn't tell me what MIMO configuration they had on the base station, assuming it's some massive MIMO configuration. Line of sight, they say it can go up to about 300 meters, 28 gigahertz. And then again, a lot of data was missing. But the problem was, it was, they had some kind of a fancy setup here, and antennas, and it's going to heat up. And then again, the simple fact that limited human perception, more to limited human perception. This, at any one point of time, you may see a high definition video on this phone. That's it, mobile. Worst come worst, a high definition video will take about 5 Mbps downlink bandwidth. That's all it takes. And so definitely mobile use case is not, unless until of course we're talking about having a base station instead of a car or a connected car which is consuming a hell of a lot of traffic, a hell of a lot of data. I quite don't understand that, but still. Even in those cases, so it's very clear that the use case scenario is indoors. So if the use case scenario is indoors, that means you're stationary. First of all, the general understanding is that for any multimedia data consumption, you've got to be sitting in one place. Maybe you may not be driving, so this is a car case, but otherwise you're still sitting in a place. That means you're stationary, you're not necessarily mobile. Whereas in the case of talking, you're walking and talking. It doesn't happen to be the case for video. So it's strictly indoors. And that being said, there are a lot of specifications which you expect to be in place to deploy this indoors. What are those? 5G is predominantly looked at as a. So you have to bring 5G into the home, you have two options. One is you have a CPE, you have a cell looking into an apartment outdoors, but you have a CPE. Some kind of a high gain antenna CPE which is looking straight into the base station, and you get all the throughput benefits and stuff like that, design benefits, and then bring a fiber into the home or a Ethernet into the home, and then Wi-Fi you get connected everywhere or something like that. You plug in a. So what that means is, so here is a channel, here is an opportunity for wireless to replace cable. Today we deploy, in LTE we deploy about 3 channels of EMBMS. 3 TV channels are broadcast. The rest of the stuff is all largely demand, it's all unicast. There is nothing. Only 3 can be supported because in TDD type 2 configuration, which is downlink heavy, even to support 3 channels of TV, you take up 2 sufferings, which is spectrally very inefficient, it's a mess. So what can we look forward to in 5G? In 5G we have a clear opportunity where we can clean up these inefficiencies of spectral usage, especially with respect to TV broadcast. That's one of the key things. Because if you don't do TV broadcast, or even if you do video on demand or whatever, there's a lot of inefficiencies because in a country, it's very good to talk about 5G as an access technology. I mean, where is the fiber to take all this? If I have 3 5G cells inside of this campus, each of them blaring about 3 Gbps downlink or whatever throughput, where is the fiber to take to the rest of the world? I mean, you are totally disconnected. 3 Gbps into 3 into plus a few more things, you're going to have that fiber capacity running just out of this building, just to support 3 base stations. So here the fiber penetration. Fiber penetration in India is pretty bad, so backhaul is a big concern. So EMBMS broadcast is a critical technology that has to be developed on 5G. Some odd reason you go to 3GPP if you're an active participant in 3GPP. There's not much of an interest in 3G, EMBMS specification. Of course, we are trying to push. I go there and I always fight it out. But yeah, it's going to come in release 16. But then from the rest of the community, there's not something. I really wonder, I mean, if that is not the case, what is the rest of the world looking at 5G for, given the efficiencies that we have? It's really it becomes a very questionable technology. I mean, if you do not really bring in a good service architecture into place and do all those optimizations to clean up the efficiency, spectral efficiency, specifically, for example, on a specific case of EMBMS, just an example. So, virtual reality streaming, all those stuff is far away. I don't believe in that. Video-driven mass entertainment, total bullshit. Robotics for logistics, crap. End-to-end fleet management delivery, I mean, come on, I mean, there's already fleet management stuff which is up and running on a 2G technology. I mean, why does one want, unless until of course you have cameras and backhaul. Then again, even if you look at the camera case, I have a camera and I need a backhaul technology. Most of the people today are thinking about fiber as a backhaul technology for camera and all the streets everywhere, and taking the live feed to somewhere else. Even if you were to use 5G as a backhaul, where is the 5G backhaul specification in place? It's not, we'll come to that. And connected vehicles, too many specifications, A02.11p, V2X, based on LTE, and anything related to 5G is still not started, 0. But people put all those fancy things, V2X, it's a big killer application for 5G. No. You take, in my sincere understanding and experience, if 5G specification is fine-tuned for home delivery and for enhanced TV experience inside the home, which will also cover some of your mobility cases, that would be a big success. That's not done. It's a flop, my personal understanding. You don't necessarily take it that time, but the other key thing is 5G as a backhaul. 5G is a backhaul technology. The same thing. You look at the number of use cases, you see majority of them falls into wireless, stationary case, be it stadium, be it antenna. So you have predominantly 2 classes of applications: small cells, LTE small cells, LC macro cells, and CPEs. That's about the boxes which will rule the 5G deployment scenario, in my understanding. So let's look at the backhaul part. There is an activity which is going on in switch which is called as integrated access backhaul. It's been cooking for some time and still cooking. There's not much of interest. But especially for a country like India, 5G as a backhaul technology is a serious consideration. Because we are expanding like nobody's business on LTE. Competing operators are also deploying. We have a better fiber coverage, fiber penetration inside of India. Other operators are even worse, they're not as good as us. Whatever it is the general interest of any operator, not just an operator, even for the country, for you to really have good connectivity. Backhaul is a big concern. And 5G as a backhaul is a viable option. 5G as a backhaul is a really, really viable option. And I think that this is integrated access backhaul is a viable option because if you look at a typical deployment scenario like this, you see how many number of this, what is the dependency on the backhaul? Every between base stations and base station to the core network and home to base station. If you look at the predominant distribution, the case is made out for 5G as a backhaul or 5G TTX or WTTX as a replacement, as a fiber replacement. So what is integrated access backhaul? Integrated access backhaul is you have a huge spectrum, big spectrum, 100 megahertz. So for example, that is what is auctioned in India. We get 100 megahertz, which is doubtful, but anyway, that's what we assume. The base station will assign some amount for the access and some amount of bandwidth for the backend. Flexible, it's supposed to be dynamic. Then the specification is still not in place. And what are the real use cases of such an integrated access backhaul? Even though the specification is not in place, we're still hopeful that one day this will see some light. So, not necessarily if it's just backhaul, but predominantly even for front haul. The front haul fiber connectivity is supposed to be even worse than the backhaul scenario, because backhaul you can dig up the road. You can still take a corporation approval in India, you can dig up the road. You, from the compound of IIT-H, dig it inside and bring it to your building. That will be the major problem, because then it has to go through the local. You can take government permission. There's a private permission. You have to take direct trust to sign. You have to get consensus from 10 guys. And it's a mess. It's not easy. This is in an institution, but in a residential complex, it's even more, because they call a committee and they say, okay, 10 people vote for that, and one hand extra raises for nay, and then it's killed. So, why am I saying this? The last mile fiber penetration is even more a challenge, because of which you throw some beautiful concepts like Cloud RAN. It's all fine, but Cloud RAN in an enterprise or in a home scenario, what it assumes is that you have all this antenna arrays and then consolidated base station somewhere else, not necessarily outside of your campus, but inside of your campus itself. And you are trying to provide fiber from those remote radio heads into your own base station. And just in case base station happens to be across the road, you're finished. I mean, you get into that political quagmire of how do I dig and how do I cut the road and how do I jump the compound and come inside your campus, and then that's a major problem. It might be easier to visualize in the case of an institution like this, but then go to a residential complex, it becomes a pain. It's not easy. So CRAN deployment is really constrained by the fiber penetration in the last mile into the homes, into the enterprises. Enterprises are still okay, and you can always talk them out to benefits. But so, in order to have a viable front haul technology, you know CPRI specification. CPRI specification, people claim 5G doesn't scale up because you're talking about GBPS of data. So CPRI, we need a new specification, and there are different flavors of CPRI. Even if you have Europeans working on some flavor of CPRI, we in India, TSDSI, we have a flavor of CPRI. Interoperability becomes a question. Then they're all a mess. But in spite of that, so here we have an opportunity with respect to the 5G specification where we can clean up this mess. We can have a decent IAB specification, integrated access backhaul specification. We'll also cater to front haul. it has its challenges. Which flavor of Cipri do we put on top of the radio interface now? So that's another challenge. But yeah, I mean, at least it looks promising. This is an example of typically for the specific EMV in this case. So we've been talking about this interactive TV for a long time. Never happened. Even with fiber, it's not happened because it takes a lot of intelligence. Now you might pull a fiber into your home. A lot of you have fiber into the home, but then there's a set-top box, and set-top box has to have a lot of applications. Interoperability is still an issue there. What kind of application do you do? At least nowadays, you're saying these Android set-top boxes, you can pull in some TV content and you can directly stream TV content to your home on demand and all this stuff. But then the amount of penetration is very low because of the fact that fiber penetration takes its own time as well as money. Whereas 5G, CPE to set-top box to TV connectivity is no-brainer. So there's been a lot of discussions on. I'll quickly skim through a couple of other issues. I've not gone into detail, but I'm just giving you the details of what are the key issues that you will see going forward. First specification is out. That's fine. Great. But release 16, release 17, release 18, what can you anticipate, expect, or what is it? What will be the nature of 5G specification as it evolves is what I'm trying to throw at you. Look at this critical communication. We've been talking a lot of critical. 5G will come, holy grail, it will solve all critical. We can connect industries and all that stuff. So just to give an example, you guys were here yesterday. There's an example of 95% of robots that India buys, especially automobile sector and all. So manufacturing is going strong in India. 95% of the imports are from Japan. Robots. And of the 95% from Japan, there are only two companies that dominate. I forget the name of the companies. There are two predominant companies which they will not throw open their APIs. It's a closed system. You buy a robot, they will come service. They'll come. They'll say what it has to do. They'll program it and they'll go. That's it. You're just a blind spectator. Oh, it's doing its job. I'm fine. Done. That's it. You cannot integrate that with your distributed control system. You cannot integrate that with your whatever master control. You cannot do anything with that because that is the way it is, and you cannot hack into it. You cannot crack into it. You cannot plug it into anything else. You cannot do that because it's a closed system. It's a vendor lock-in. So, so how does 5G help here? Unless and until as connectivity, it does not help unless and until you cook up some kind of a a middleware layer. Here the data is shown as a controller, but that controller specification is outside the scope of 3GPP, unless until you bring it into the scope of 3GPP and you say that there is this set of APIs. Underneath, all these vendors, you do whatever you want to do, but please open up a set of APIs to me on the top, on the northbound interface to do whatever I want to do. Integrate this into the rest of the factory, the rest of the operations, the rest of whatever in a factory. These are key. We do not see any of these things happening in 3GPP. And yet, we get to hear a lot about 5G as the holy grail for critical communications and stuff like that. Critical communication, emergency communication, that's fine. I mean, in India, nobody even talks about emergency communication. We talk about integrating our network into emergency communication. The nodal government server is sitting there. It's not even alive. It's not even awake. So these are the critical challenges that we have. And unless these challenges are broken up, if anybody tells you that 5G will come and solve critical communication, crap. Mobile edge computing, again, a lot of efficiencies can be had. Only practical application seems to be, bring the data to the edge, do whatever you want to do there. But yeah, bring it to the edge. But then again, how you bring it to the edge and what you do with the different specifications, going all the way from HTTP level REST APIs to IETF has some specifications. 3GPP is not working on this yet. But the question is, there are proprietary solutions. There are tons of companies who come and claim they can show you these kind of visions. The fundamental problem here is interoperability. Interoperability becomes a key issue here. The nature of data that you're bringing in is different. See, when you talk about data at the edge of a 5G system, for example, you will have a lot of radio-related information which is coming in. Typically, we handle it at the SON, self-organizing infrastructure. There's a SON server that happens. There is a ton of information which is coming in from the UEs, radio application, whatever other related information which comes in. This is all in the uplink. That's all radio related, network related. In the downlink, you have the multimedia data streams or whatever data streams which are going down, which you may want to come and bring it and cache it at the edge. If you want to cache it at the edge, you need to know precisely what a group of set of users inside of that coverage area are using. You need to have some kind of, assuming that you do have it, you bring it in. Now, the question is, what do you do with that? I have a set of radio related information which is governed by a SON specification, which we have all those user data which is coming in, which is not governed by anybody. I can just bring anything in, all proprietary solutions in place. Can I have an integrated edge computing platform? Can I conceive of it today? Yeah, if I want to go the proprietary way and force every single vendor to cook up, which is a nasty, long drawn process, yeah, I can do that. But there are no specifications in place. Mass adoption is a serious problem unless specification is in place. And NFV SDN, 5G, NFV SDN, it's all supposed to be, for some odd reason, NFV SDN specification, look at NFV SDN specification anywhere, IETF or 3GPP, network slicing, it all assumes that 5G is sitting in a silo. 5G is sitting in a silo, so come take this technology, implement. 5G will never sit in a silo. It's going to coexist with your existing 4G network. So hybrid network management or orchestration or provisioning is something that is unthought of, not in 3GPP at least, and not in a lot of forums. There is some forum called as TM Forum. I don't even know what it stands for, TM Forum. They have some specifications which talks about open APIs, some kind of integrated, it's just coming on. But then again, because of the fact that there is not 3GPP, they have gone above the network and say, okay, whatever be your network underneath, I'll go 1,000 feet above and I'll put up an orchestration mechanism there. And if I want to orchestrate again, then you have mediation devices underneath. Those mediation devices will in turn talk to your whatever network elements, and then that's how it works out. But then again, there is assumption of mediation devices and too much of these assumptions which happen. It's not a very straightforward thing. If I take the TM specifications today, which in itself is very raw, it's just about 2-3 weeks old, and if I were to implement it, and if I were to give a roadmap, see, for example, as an operator, Reliance Jio, if somebody were to come and ask me, give me a roadmap on how to implement 5G today, and make sure that you don't touch any of our existing operations, 4G, but still give me a roadmap to implement 5G with its orchestration, with NFV, with whatever. It's a tough call. It's a tough job. It's not an easy thing. So a lot more needs to be done with respect to interoperability specification on 5G. But then again, there are some operators who have taken a proprietary approach. They say, okay, there's nothing much happening here. I'll drive it. AT&T is going that way. AT&T says, okay, I'll bring in all those startups. You go to AT&T, all their NFV SDN strategies being driven by startup companies, which apparently, if you go to their website, are in stealth mode. Nothing. You don't get any information about them. So you don't know what they're cooking up. So it's predominantly proprietary. And proprietary is all fine. It's good for AT&T. They've got enough money. Okay, I'm going to put in enough engineering force. I'll do it. Not necessarily true for every single operator. Scale again becomes an issue. So at a summary, and this is precisely what it is. Some of the open issues. This is not an exhaustive list of all the issues. I'm not trying to go that way, but I'm trying to put across. There are serious issues in realizing 5G. From the first specification to actually seeing 5G in a field. I'm not talking about labs. People who say, I got 5 Mbps, I beat that person, I got 6 Gbps downlink, sorry, Gbps throughput downlink. They're all great to hear, but in the case of virtualized network, MIMO is the IETF thing for orchestration, specification for orchestration. How does that work with OSS? How does it come down to different architectures and RAN from a 5G perspective, which is centralized or distributed in nature? How do you plug it into those element managers? Those are all still open issues. So, in summary, what I just wanted to tell you was 5G base specification is in place, and if anybody ever tells you that 5G is ready to go, they are sadly mistaken, or unless and until some of these questions are answered. We still have a long way to go as far as 5G is concerned. But mind you, this also shows the amount of opportunity there is. To plug in, and that is precisely the point that I want to emphasize. The opportunity there is for the Indian ecosystem, for the Indian standardization efforts, for new standardization efforts, for harmonization of multiple of these issues which are still open. So there are a ton of opportunities going forward, and with that note, I end my discussion. Thanks. Thank you.
Any questions? Yeah. Mic is at the back side. Yes, yeah, you can start.
Okay. So
This question is from.
So the basic question I have is that IIT 2020 has defined a vision of what potentially could be 5G, or in terms of the requirements, specifically the performance requirements, which is 10x, 100x, and the latency is 1/10 or 100, So they have. So what you are saying that what is happening in 3GPP as a proposal for IIT 2020 may not meet those specifications that we do. There is a huge gap, and a lot more information. Whatever release 15 is being discussed today does not meet that.
Yeah.
Maybe there is a lot more that needs to happen.
Yeah.
Release 16, release 17 to meet. But the IIT 2020 performance specifications that have been specified are really the vision of where it needs to go.
Yes.
Right?
That's true. So the way 3GPP handles that is, as long as I don't have a competitor, even my low performance is good. So I'll still take it to IIT 2020 because as long as IEEE is not bringing in a competing standard which says he's 10x more than me, I'm perfectly fine. So my mediocrity can live as long as I don't have competition. So that is the approach more or less. But then again, there's the other thing. For example, 2019 we take the first. All the SDOs will take the first proposals into IMT 2020 against IMT 2020 considerations. There again, it's still considered as the first draft submission. It's all in bits and pieces. For example, if you look at 3GPP, the way discussions are happening is there will be one specification which will which will carry the latest NR specification, 5G NR specification. The other one is Narrowband IoT specification. They're not even talking about URLCC as the massive MTC requirement thing. So 2019 is going to happen, 2020 something is going to happen, 21, 22, 23 probably you may have more serious technology which will go to IMT 2020, which will come closer to IMT 2020 things. So that is a big opportunity for us. And that's also a big opportunity. We have enough time to work out things. We're not late. For the first time we're not late on the telecom scene, unlike LTE. Here we have sufficient amount of time. So it's a big opportunity for us.
So this question is regarding your statement on eMBMS, wherein you said that you are still seeing that as a relevant part in 5G. So, I mean, eMBMS was traditionally used for as a solution for optimizing the radio resource when more than one person is viewing the same content. But over the period of time, we have actually gone to a state of video on demand already. And with 5G, when you have much of spectrum in place, do you still see eMBMS relevant, or 5G as a bandwidth on demand takes over and rules this out?
Yeah, so video on demand is still, if you look at some of the data coming out from broadcast associations and some of these associations, video on demand is still, I have 130 channels today in my house. The movies, some of the key serials, assuming that I don't have time to watch it, there's a segment who watches it offline, so that is video on demand. Movies, predominantly video on demand today. And there is still a substantial amount of content, 70% of the content, which still comes on broadcast. It still comes on your cable, which is like, essentially. And the opportunity, I'm not talking about what eMBMS has gone through in the past. Let's look at the opportunity from the future. Assuming that I as an operator, you bring in eMBMS framework into NR. NR has 3GPP downlink, assuming that one cell has 3GPP downlink. So 3GPP downlink is where in LTE I was supporting 3 channels, I can support about 40 channels here, 40-50 channels give or take some based on the HD-ness of the content that you push in. So 30 channels literally means you have the opportunity to take over the cable business today. And that is the opportunity that stands in front of the operator. And who says no? Why would I say no to that? Give me a good EMBMS acquisition and I will try and see if we can shove out the cable operators. Forget about the cable operators. What does that give me? It gives me a ton of other opportunities to monetize, because today in your TV content, who puts in the ad? The ad is put at the node, at the end, head end, whatever, Star TV, he's the one who controls the ad. No, if it becomes IP, if it's a dash which is coming in live or non-live, I as an operator, somewhere in the pipe, I can plug in and I can push an ad. So the head end is dead. Not dead. Whatever. It can shake up. The reason I'm so bullish about EMBMS is it has the potential to shake up a lot of inefficiencies in our distribution system, the content distribution system today, including broadcast.
So any other query?
As for the backhaul that you were mentioning, aren't relays helpful over there to cover the...
Yeah, in IT we have the relay specification, but the challenge was if I only have 20 megahertz of bandwidth, and if you have to locate part of your subframes for backhaul, it doesn't work out. 20 megahertz. See, look at the spectrum. It all depends on the spectrum. If I got in Australia, for example, I would, they're sitting on excess of bandwidth. Given their population, they're sitting on so much of bandwidth. It's a wonder. It's like they have, for LTE deployment, they have something close to about 500 Mbps of bandwidth. We're sitting on 20 plus 10 plus 10. You take that other FDD spectrum. Something about 40 megahertz is all that we have. So distribution there between fronthaul and the backhaul for a relay LTE is a bit of a tricky thing. Whereas in NR, for example, if you say 100 megahertz, at least people talk about 100 megahertz, if you take 100 megahertz channel, it's a much bigger scenario, a better scenario to split than splitting 20. You get bits and pieces. It's a bit of a tricky thing managing that. And then again, the other thing is relays, the amount of data which is generated in LTE is not the same as is expected to be in 5G. 5G is supposed to be much more higher, so your backhaul becomes equally important when compared to fronthaul. Whereas in LTE, it's still okay. I mean, I multiplexing multiple technologies, and then I sort of on an average I can manage kind of thing. That's one of the reasons why I did not take off LTE. But whereas in 5G, trust me, it's going to become crucial. Both fronthaul and for backhaul. Fronthaul for CRAN kind of deployments. And
the point is, if the relay technology is improved, if 3GPP works on relay technology, isn't that problem that you mentioned about the backhaul gets nullified?
Yeah.
If the relay technology is
now, if you look at
forward.
there's also commercial angle to the way LTE relay technology has evolved. You look at the dynamics of the relay. There is a relay node. For all practical purposes, a base station, and that backhauls on whatever resource. Let's forget about the resource constraint. You have all the resources in the world. It backhauls to something called a donor in node B. Donor in node B is some mega node B, additional capability and all the stuff. So the challenge, the business challenge there is, I don't know where I'll put up a relay. I'm silent right now. Somebody gives me a call and says, he cries, oh, I don't have any connectivity there, I'm in a remote corner, why don't you put up something urgently? Then I can think of a relay. But the problem is to immediately go and put that, my existing E node B should all be donor E node Bs, because I don't know where the call will come from. Now if I want to span out a countrywide donor E node B, which is another 60% cost addition to my existing cost, I take a backseat because 60% overhead for 2-3 odd relays that I might put up across the country in some cellar and some places where there is no coverage, and it's a big deal. Whereas if you look at NR, it's a different call altogether. There the business case was not spanning out. Here the business case does render itself to you because you need to have a fiber in the fronthaul itself in the first place, and your backhaul. The amount of data that is coming in there is more. And you're not talking about isolated cases here. You're talking about every single CRAN that you possibly might deploy will need to have a front door for which you can as well use this. So scale of business is a combination of technology, business, multiple things play out.
I think in the interest of time, let's stop here and take the questions during the coffee break. I think Satish has given very interesting and realistic case of where the 5G is currently and also thrown a challenge to all of you, what you guys have to do, especially in the context of India-specific needs of the 5G. So I think with these few words, I stop here and ask Satish to come here to collect a small token of appreciation from NCC 2018 and IIT-Hyderabad.